So in this example, we want to find the orthocenter of the triangle. And the way we do that is we find the intersection of the orthogonals, perpendiculars, altitudes, whatever you want to call them, and where they intersect will be the orthocenter. So in order to find the orthogonals of the perpendiculars, the altitudes, whatever you want to call them, we have to look at these coordinates between these points and find where the perpendicular line to this segment right here is, and what the equation of that is, and find out where those lines intersect. So what I mean by that is we're going to find the slope of this line, we're going to flip it and negate it to find the perpendicular slope of a line that hits it at 90 degrees. And then we're going to make sure that line, that 90-degree line, intersects with that opposite vertex. So we're going to have a line dropping from here, hitting this at 90 degrees. Now you'll notice because of the shape of this triangle, it's going to take a lot of doing to make this a 90-degree angle. In fact, we're going to have to go outside the triangle just a little bit to do a 90-degree angle from C to AB. So here's what I mean by that. We're going to find the slope of AB. So the slope of AB is going to be the rise over the run between the y's and the x's. Well, the y of A is -2, and the y of B is 1. The x of A is -1, and the x of B is 6. So the slope between them is going to be -3 over -7, which is 3/7. So there's our slope of 3/7 between AB, which means that the perpendicular slope is going to be -7/3. So the line that hits this at a 90-degree angle is going to be a slope of -7/3. Now, there are lots of lines that hit this at a 90-degree angle. We want the line that also hits at a 90-degree angle and goes through this vertex. So we want an equation that looks like this and also hits this point, C. So it also hits 6, 5. So what we do is we take those points and we plug them in to our equation and solve for B. So 5 was y, and x was 6, and B is what we're solving for. So we do 6 times -7/3. Well, that's 6 divided by 3, which is 2, and times -7, which is -17, or sorry, -14. So 6 divided by 3 was 2, times -7 was -14. If we add 14 to both sides, we get 19 equals B. Therefore, the equation of the line that hits it at 90 degrees and also goes through point C is going to be this guy right here. So that's the equation of the line that goes from here to here and hits it at 90 degrees. You'll notice that that equation is probably going to be somewhere over here, hitting it at 90. We need to extend out that side a little bit because this is an obtuse angle. So there's our first line that goes from here to here. If we find another one, maybe by finding the slope of this segment right here, AC, finding the perpendicular line to it and what goes through B, we can find the intersection of those two lines, and that will be our orthocenter. So we found the slope of AB, we flipped it and negated it to find the perpendicular slope, and then we plugged in C into this equation to find the equation of the line that goes through C and hits this segment at a 90-degree angle. We're going to do the same thing, but for AC this time. So instead of finding the slope of AB, we'll find the slope of AC, which is going to be the y's minus the x's, or the y's minus each other and the x's minus each other is the slope formula. So the slope, or the y of A is -2, and the x of A is -1. For C, the y is 5, and the x is 6. So if we find the slope between them, we get -7 over -7, which we know is the slope of 1. So the perpendicular slope is going to be -1, or -1 over 1. So the equation we're looking for is going to be -x plus b. And we want that line not only to be perpendicular to this side to hit it at a 90-degree angle, but also go through point B. So I'm going to plug in 6, 1 and solve for B. So I plug in 1 for y and 6 for x. and I solve by adding 6 to both sides, and I get 7 equals b. Therefore, our equation is y equals negative x plus 7. So those are the two lines that hit this side and this side at a 90-degree angle and go through the vertexes C and B. So if I were to just sketch these really quickly, you notice that this would go somewhere around here to hit this at a 90-degree angle and go through C. This guy would hit this at a 90-degree angle somewhere around there. Extending those out, we should have a connection over here. So let's find those connections. And the way you do that algebraically is set these two lines equal to each other, because where two lines equal each other is where they intersect. So I'm going to write those two equations over here. I'm going to take those two equations, I'm going to write them down, and I'm going to set them equal. So we have our blue equation. I'm going to set it equal to our red equation, negative x plus 7. And we're going to solve for x, and that's going to get us the x coordinate of where they intersect, and then we're going to go back and take that and find the y coordinate later. So first we just do some math. I'm going to add x to both sides. When I add x, that's 3/3 x being added over, so it's going to be negative 4/3 x. When I add subtract 19 from both sides, I get negative 12. Then to solve, I'm going to multiply by the reciprocal to both sides, so I'm going to get x equals this negative 12 times the reciprocal of this guy, which is going to be times negative 3/4. So if I times it by negative 3/4, I'm going to get a positive answer. 12 times 3/4 is going to be 8. Am I correct in that? No, that's a third. So it's going to be 9. It's going to be 9. So x is 9. Again, I multiplied by the reciprocal to get rid of that negative 4/3. I did it to both sides, and when I did that, I got a positive answer. The reciprocal here is 3/4. So when I take 3/4 of 12, I get 9. So the place where they intersect is at 9 comma something. I'm going to take that 9 and plug it into one of my equations, either here or here, and find out what y is. So if I take that red equation, which is the one you can see on screen, I can plug in 9 for x, and I can solve for y. When I do this, I get negative 9 plus 7. Negative 9 plus 7 is going to be negative 2. So I get y equals negative 2. So at the coordinate 9 comma minus 2 is where these lines intersect. So if I go back to my original drawing and I find 9 comma negative 2, 1, 2, 3, 4, 5, 6, 7, 8, 9 comma negative 2, that's going to be the intersection of a perpendicular line that hits C. So if I draw a line here, and the line that goes through B and hits this at a 90-degree angle, this side. Whoops. And that is going to be our orthocenter. If you chose to do the sides that hit, or the perpendiculars that hit this side over here at 90-degree angle, so if you dropped it from A going through here, you would notice that you'd have to extend this down to get 90 degrees, and it would hit there. So I'd have to extend this side down, and this line right here, which is a horizontal line, would also go through there. So this would hit 90 and that would hit 90. So what we did is we found the line that goes through B and hits AC at 90 degrees. We did that by finding the slope of AC, flipping and negating it to get the right slope, and then plugging in B to the equation to make sure that that line not only has the right slope but also goes through B. We did that as well for this, so we found the slope of AB, and we flipped it and negated it to find this slope, and then we plugged in C's values to our equation to find the equation of the line that goes through C and hits AB at a 90-degree angle. At their intersection point, we found the orthocenter, which was at 9 comma negative 2, and we did that by taking the two equations that we got from those two lines, the blue line and the red line, and setting them equal to each other. And when we did that, we found that x was 9, and we found that y was -2, and that's where our orthocenter is.